this presentation is looking at making calculations involving finding the area of any kind of triangle, so not necessarily a right angle triangle, and not necessarily a triangle where we've at first got all the information we need. We're going to do this using 3 different methods. So the first method is an oldie, so a half base times height. This is our original formula that is traditionally taught maybe year 7. So a half of your base times your height. It's basically creating a rectangle and then realizing that the triangle is going to be half of that rectangle. So halving your answer. An example of this is this triangle here. So to 1 decimal place, calculating it, base is 7, height is 3. So our area of this is 10.5. Please make sure your units is right. So this is meters squared as a unit, and then red box your answer. Another method is to use a half b times c sine a. So we're using a half b times c sine a. You've got to make sure you've got the right information. It's a cozy angle scenario where we're using this rule. So if you've got a cozy angle, i.e. 135 degrees is cozy between 6 and 5, then you can use this rule to calculate the area. So a is equal to a half times c times b times sine of a, substituting in the values I know, and then this is straight into the calculator. So a half 6 times 5 times sine 135, and this gives me a result of 10.6, and again units centimeters squared. The last formula is Heron's rule for the area of a triangle. This is if you have all 3 side lengths. So if you've got all 3 side lengths, you can use Heron's rule for the area of a triangle. Heron's rule is described as the square root of s times s minus a times s minus b times s minus c, where s is all of your side lengths added together and divided by 2. So it's called a semi-perimeter. And it's a straight substitution into your formula there for the area. Alright, so for example, side length 6, 9 and 11, I think these are fences, and I can calculate this by calculating s as half of my perimeter, i.e. 13, and then substituting it into my Heron's formula to get 13 by 13 minus 6 by 13 minus 11 by 13 minus 9. Now you can do this by hand if you wanted, or I'd be more tempted just to throw this straight into my calculator as expanded, just so I don't have some small little error along the way. I want a decimal value, so I'm writing that as 26.9814. This says to the nearest square kilometer, so I'm going to round that up to 27 kilometers squared. Note my units again, it's an area, so kilometers squared, and red box my answer.